Hey everyone, it's good to see you all here. So, a few weeks back, I posted a video on LinkedIn and Facebook demonstrating interactive foliage, which I created myself, and a lot of people seem to be very interested on how it is created and how to implement it in their own games. So, let's roll the intro and jump right in. Now, full disclaimer here before starting, I'm not a blueprint expert by any means, and this is still something I'm researching about. So, someone with an experience in scripting and blueprint will definitely be able to implement it and optimize it in a better way. I'll just be going over my process on how to use it and maybe improve upon it as we progress through the video. So, I'll be using Maya for rigging our foliage. I'll be using a simple foliage from Megascans library and rigging it and skinning it accordingly. You can use other DCCs for your rigging process, but I advise you that you use Maya because of its compatibility with Unreal Engine. Now the first things first, once we have imported our foliage inside of Maya, is to create our joints. We can create our root joint at the center of our world. Also, I can toggle the visibility of its transformation axis. Once we do that, I'm going to duplicate the joint quite a few times and place them at a location in our foliage which make sense once we simulate physics in Unreal. Now once we have placed them at their respective location, it's time that we create our rig. For that, I'm going to parent each of these joints to each other, and once we have parented each of these joints, I'm finally going to parent it to our root joint. Following that, the next process will be to bind our mesh with our rig. For that, I'm going to select the hierarchy of our rig and shift select our mesh. And under skin, I'm going to select bind skin. And with the settings that you can see on our screen, I'm going to hit apply. Now the next process is really important. It's skinning our mesh to our joints. It's basically determining how our joints are affecting our mesh. So for that, I'm going to select our joints once again through its hierarchy, shift select our mesh, and under skinning, I can click paint widths. And as you can see on the list, I can click on each of the joint and see through the gradient how it is influencing our mesh. Through the painting tools, we can paint how much influence we are creating. And take your time and paint your widths in a sensible manner. This can take your time and be patient with the process. As you can see that I'm taking quite a lot of time during the screening process. And also, as you can see, in some of our joints, the influence is not that realistic. So for that, I can remove our influence from those particular regions and paint again to make it in a more sensible way. And you can always go for back and forth and check the influence by moving the joints. Now to export our mesh to Unreal, first I'm going to select our mesh, shift select our root joint, and then export it as an FBX. So once you do that, I'm going to open Unreal Engine and import our mesh as an FBX. You can see the settings that I'm using to import it, and you can follow it likewise. Now every time you import a skeletal mesh inside of Unreal Engine, there will be three types of meshes that will be created by default. The skeletal mesh, the skeleton, and the physics. And by the name of our video, you can automatically guess that we are going to simulate and work with our physics asset. So first, open up the physics asset, and by default you will see that there will be physics bodies that are created automatically by Unreal Engine. We are going to create from scratch. So first things first, I'm going to click show all bonds and select all of the physics bodies and delete them. And let's start fresh from creating our physics bodies first. Once you click on any of the bonds for our foliage, right here on the right side you will see an option to create the type of physics bodies for your bond. Most of the time in foliage or in any form of organic object, we are going to create a capsule body, which works most of the time. Now the major goal of creating a physics body is to align and cover our bone as accurately as possible so that the physics work as according to our bones. So this can take a lot of time, and it's important that you use this time to create your physics bodies accurately. One thing you might have noticed by now that whenever we create multiple physics bodies in our joints, there are round balls like objects floating around in our joints, and these things are called constraint, and this basically controls how our bones going to bend and simulate once you hit that simulate button. Now first thing is that on our first bone, which is the top bone of our foliage, I'm going to create the physics body. And as you can see, once we select our physics body under constraint, first we are going to adjust the location of our constraint between our top bone and the middle bone, which will be the location of our simulation for our physics bodies. Now one thing you have noticed by now that whenever you create the physics body for your lowermost bone, basically the base bone, there will be a constraint created, and technically we won't be needing that constraint because we will not be simulating that lowermost bone either. And if you click on the middle bone, you can see that there are two constraints. One of them is that lower constraint. We don't need that, so we can delete it, and I can right click on our physics body on our outliner and select which constraint we are going to use. I'm going to select our base bone for that. As you can see, the constraint is created exactly at that location where our joint is. That's why I was telling that the location of our physics body should be as accurate as possible. If I click on any of the physics bodies, there are two types of simulation we can do. There is the typical kinematic and the more realistic, which is simulation mode. I'm going to set it to simulation. And as you can see that in our lowermost bone, I'm setting the physics type to kinematics, and also there will be no constraint. So basically the physics won't be simulated for that bone. Once we select our constraint, and then if we scroll down, we are going to see how the behavior of our constraint will be. And I'm going to set all the three to free. Free basically tells the simulation that our bones are free to move in any axis and swing in any axis. If we set it to limited, it basically means that we are going to use a specific angle for their motion. If we further scroll down, we can see there is an option for angular drive. If we enable it, there is an option called S-Log. We can tick it, and under each of these two values there is a number that we can type in. For it, I'm going to type 1000, and below it I'm going to type 2. I don't exactly know what this lower value does, but for the first one, higher the value means that the plasticity of our foliage will be more. That means that we are going to need more force for it to deform and simulate it. Now for this constant as well, I'm going to repeat the same step that I have mentioned you earlier. Once we have done this entire process of adding constraint and physics body for all the bones in our foliage, we can open up the demonstration map that I have created for the video, and I can drag our skeletal mesh into our viewport and maybe duplicate them, rotate them around, and create a clump out of it. And you can see that I'm using a sphere as a collider object. Now once I hit simulate and if I move the sphere around, you can see that our foliage is acting like the way we want him to. Now you can see in the viewport that all those foliage that are getting simulated are basically scattered manually by myself. Now the most important and the obvious question that might be arising from your mind is how do you even implement it in a real scenario? That's basically using the foliage scattering tool and using it in a scatter system that we can later use in creating a large forest or an open world. For that, I opened up Google and searched a few forums for the answer, and as I have realized by now that there is little to no tutorial online for topics like this. But on the dev community of Unreal Engine, I managed to find this particular article, and there the writer mentioned about this guy who has created an entire series about interactive foliage. And when I opened it, the videos are quite old by now, which is like 7 years by now, but things are quite relevant in current situation also. I'll be linking down the video links which you can watch and dissect them for yourself. Now for myself, I have created the blueprint by following the video, and I have tried to understand and make it simpler for you to understand as well. So let's jump into the blueprint and let's work our way through it. Now before we head over to blueprint, there are a few things that we want to take care of. Firstly, we'll need the player character in our level. For that, we can go to this add button, then click on add feature and content pack, and here you can select any of the player presets you can use. So there could be first person, third person, or the top down. Here I am using top down. So inside of it there will be a blueprints folder, and inside the blueprints folder there will be our top down character, which we'll be using in our blueprint creation. Secondly is that since we are using our skeletal meshes in our level, we need to create blueprint out of them. So as you can see, I have the skeletal mesh and there is a blueprint class. So how you can create blueprint class is simply select blueprint class, and under actor you can just create the blueprint and drag and drop your skeletal mesh inside of there. And let me delete it first. And also, since we are going to scatter it in our foliage editor, we'll also be needing the static mesh of our foliage. So for that, you can just open the skeletal mesh, and here you can see there is an option to make static mesh. So just click it. You are prompted to write the name of your static mesh, select the folder where you want to save it, and just click save. Alright, now let's get to our blueprint stuff. So as you have added your player character, I'm using the top down character here. We can just double click it and open up our event graph, and you can see I have gone ahead and created the blueprint from start to finish. Now before we create our entire blueprint, I want you to create a structure. So just right click, blueprint, and structure. So inside of the structure, we want to store a few data like the foliage transform that we are scattering, the foliage index, the types of foliage that we are instancing, the foliage actors that we are using, and also our blueprint. So all of them are needed to actually make the entire blueprint work. So now if I jump inside the actual blueprint, and again I'm repeating this that I'm not a blueprint expert by any means, so I have followed the tutorial to create this, and as per my understanding, this is how I going to approach the entire process of using the blueprint to create interactive foliage. So first thing is that we are creating an overlap event because the player will overlap with her foliage. After that, there will be two sequences. The first one will be to reference our static mesh foliages with our blueprint actors that will be simulated once the player interacts with our static meshes. And the second part will be to remove all the rest of the foliage from the blueprint class back to our static meshes. So firstly, we are going to trace our foliage using a sphere trace, and we want the sphere trace to move along with our actor. So I just gonna add the actor location and put it on the start and end position of our sphere trace. After that, it is going to output an array which will list all the components that our player is hitting and overlapping. So after that, running a for each loop, and we're gonna get quite a few data. So it is the initial overlap of our foliage, then the hit actor that our player is actually hitting, and also the object references. After that, I'm gonna cast our hit components to the instance static mesh component because this is the foliage that we are painting with our foliage editor. After that, I'm going to get the transform of our instance static meshes from the foliage editor and try to copy it to our blueprint actor so that the transition is seamless. After that, I'm gonna create an actor reference and add the blueprint actor that we are using currently, and then spawn it over our static message whenever the trace is trace ran over the static message. After that, I'm going to store all the data in an array edition. So this will be our instant static transform, and then the hit item that we are hitting, and the actors that were, and also the hit component. After that, I'm gonna remove the static meshes with our blueprint actors. So this is the first part. And since we have added it here, we can reference it back to our blueprint through this process. So I'm pulling off the array that is referencing to our structure that we have created earlier, running a for each loop once again. And then I'm gonna break the foliage transform. So again, these are the elements that we have created in our array. So the transform, index, actors, and blueprint foliages. And then I'm gonna get the location and compare it with our actor location. And then whatever the differences will be, I'm gonna just get the distance of it and then compare it wherever if it's greater than the range that we have specified. So in my case, I just want the blueprint actor to be restricted to 500 units of our player location, and rest will be just destroyed. So it basically means that whatever foliage that is outside of 500 units range will still be the static meshes that we are painting with our foliage editor. And once again, I'm just gonna get the component class. In my case, it is the foliage instance static mesh component, and there is the foliage index and our blueprint foliages, and then combine all of the array back to our instances. So here the add instance, and I'm gonna add the transform and our target array, and just gonna remove all the data that is outside of our blueprint foliage. Now before we actually move ahead and work with our foliage and paint it, for it to actually work properly, we need to perform 3 steps, and these are really important. So first step will be to, if I open up our physics asset, in my case I'm using this foliage. So if I just double click it and select all the physics bodies that we have created earlier in the video and search collision, you'll find this button, and under here it will be set to something else. You just have to set it to physics only because we don't want collision to happen and block our character's movement. Second thing will be to, inside our foliage editor, if I click it, all the options available are shown below. And if you scroll down, you'll see an option of collision presets, and you have to set it to overlap all dynamics because our event is an overlap event. So this will be the second step. And third step, if you open up your blueprint and go to viewport and select your foliage, and on the details panel, if you search collision, you have to set the collision preset to block all dynamics. I don't know what it does, but putting it to block all dynamics actually worked properly when I was testing it. Now, if you have followed all the steps properly that I have mentioned so far in the video, we are finally ready to paint our foliage. So I'm just gonna click it and delete the earlier foliage that I have painted, and I'm gonna open up the foliage editor and drag and drop our static meshes. So in my case, I was using FernX02, so go in here and drag and drop this one. And like I mentioned, I have to set the collision preset to overlap all dynamics. This is really important. Set the mobility to movable, because if you add wind, if you keep it to static, it will get quite a lot of artifacts. And set the scale to maybe 0.8 and 1.1. And align the max angle to 10, random pitch to 6 maybe, and we are ready to paint. So let's just paint our foliage like this. This should probably work, I guess. Alright, let's see. If I hit the play button, this is the viewport. Let me just maximize the view by pressing F11. And if I just move our character, see that our foliage is actually working, that we actually been working for so far. And I wanted to look at the corner of our screen. So as you can see, these foliage are moving right now, and if I move quite far away from them, you'll see that they're transitioning back to the static message. So you can see that they are transitioning back to our original static message and keeping the transform as it was before. This is actually quite fun to play with once you are done with all those hardwares. Now I thank you all so much for making this far into the video. The link for the blueprint will be available down in the description. You can follow us on Instagram. The link again will be available down in the description. And I want you, the viewer, to go to the comment section and let us all discuss how we can implement this entire framework for multiple assets, multiple foliages to create an interactive experience. Let it for games, let it for any real-time application. Now, if you are new to this channel, subscribing the channel greatly helps. And if you are already a subscriber, liking and sharing the videos greatly help. And with all that said, I'll see you in the next video.